Hello, hello. Can you guys hear me? Oh, finally. Hello. Can you guys hear me? I can also hear myself. Oh, finally. Hello. Can you guys hear me? I can also hear myself. Oh, finally. Hello. Can you guys hear? I think now should be fine. Yeah, guys, we're in the game. Apologies for the delay, and thank you for staying with me. To be honest with you, I had no idea that it's going to be that hard. But hey, I mean, okay. Um, yeah, thank you for your patience. I'm happy that you managed to join me. And my name is Georgie. And I guess some of you might have seen me on awards. Some of you might have taken my awards courses. And I had this idea for a long time that my content should be kind of free, should be open source, and I would like to have more interactive audience, and we can do stuff together, and we can figure out stuff together. So I had for a long time, this idea in my mind that we can do some WebGL and even some stuff that is not perhaps that much used, such as WebGPU and Apple Metal. I think like these are keywords that are really thrown around, and people kind of have like a general idea of like WebGPU is this new API, right? But I don't think that there is many people out there who have actually done um, some stuff with it. And again, my idea is to make the same animation. We're gonna do it with WebGL or with WebGPU, and we're gonna do it with Metal. And yeah, explore the different APIs and do the. I think I can pop out the chat. Yeah. Um, so today I would like to start with setting up the repo. Like I would like to immediately jump into the code and we can set up the repo together. You can, for example, make sure that you can clone it and run all of the files inside it, and we can get to program. So, all right. I mean, hey, we can already start. So actually, earlier today, I prepared a repository uh, on my profile, which should be this one. It is public, so I'm gonna paste it in the chat. I guess it's really nothing inside yet. And obviously, guys, like if you have any questions or something is uncertain, like I made sure to pop out the chat. So please, always you can interrupt and you can ask me questions. All right. Uh, Perhaps like I can ask, does somebody have some experience with WebGL here? Or maybe you guys can answer while I'm setting it up. Yeah, I know it's empty. We're gonna do it right now. So I would like to do the Vite.js. Perhaps you guys have heard it. It's basically this really nice front-end bundler. So let me yeah, it gives us the instance server start and hot module reloading. So let me quickly go to npm Vite.js. Let's install it together. And this thing. Mhm. You use it for a project, like did you use it with Free.js or did you use it without any libraries? Okay, JSON. We are gonna do source new file index.html. Let's do the WebGL demo here. And the cool thing about Vite. Oh, sorry, you said that you have used Vite. Okay, cool. So, like the cool thing about Vite is that it compiles all of our files. It's not just JavaScript. So I can do directly, like, let's do dev, I guess. And I'm gonna say Vite source index.html. And it should be easy as that, right? We have added it to the package JSON, so I guess I can do like npm run dev. And this will open the server on this post. So I am gonna commit bootstrap. Yeah. Right. Cool. So a little bit about WebGL. WebGL is actually a really old standard. If you think about it, WebGL is based on OpenGL ES. So it's actually a standard from 2007, which I think in today's technology world is basically means it's dinosaur, right? Um, we are gonna see how things are done. Um, the way I always approach it is we are gonna draw like single point on the screen, and it's gonna be 2D, one point in the center of our screen. Because once we get that going, then we can see the rendering pipeline. Uh, Basically, we will cover the rendering pipeline, and then it's very easy to upgrade to drawing lines or triangles. It's easy to upgrade it to 3D as well. All right, so I think now this is the server that I'm running. Is HTTP. It's not opening. Not determine entry point. Which is bizarre. It's in the source index.html. Or should it be like a script file? Perhaps I can give it a try with a script file. To be honest, I have not used Vite.js in quite some while, so we can quickly figure it out together. So I'm gonna, okay. Now it's serving, should be the index.html, and that's very bizarre. It should be, okay, like let's quickly read the documentation. Vite config, and gonna do the serve. Okay, but that's cool. But like, what is the most vanilla thing we can do? Config with my config. You know what? I don't want to bother with this stuff right now. Like, we can start just writing in the index.html file. I think that's okay. I don't want to bother us with build steps. And like we can start just writing in the index.html file, and after the stream, I can make it formatted a little bit better. So what I usually do is I install as a developer dependency HTTP serve, and I do the HTTP serve punct HTTP px like so. And now hopefully at 8080 this will open my index.html file. And for now, I'm just going to write inside. So we have script. All right. So first thing I'm going to do is I'm going to get a canvas element. The canvas element is basically the special HTML5 tag, which allows us to programmatically draw pixels onto. It's almost as if it's an image, but we have access to programmatically draw pixel contents into its buffer. So I'm gonna do a canvas, and the ID would be just C, and I can just self-close it like so. So JavaScript, we have to get a reference to the canvas. Document get element by ID. The ID is C. We need to obtain the GL context. And I forgot to say, like, we have two versions of WebGL out there. We have WebGL 1 and we have WebGL 2. I'm going to use WebGL 2 because it makes things much more straightforward and it's supported everywhere. So WebGL 1, I guess, is legacy at this point, and I would not really use it for new projects. For example, if you use Free.js, they also have a WebGL 2 renderer by default at this point. So the context that I'm interested in is WebGL 2, like so. So next thing I would like to do is size my canvas. And to size the canvas, I'm going to set its contents to the inner width and inner height like so. And this works. However, we have to take the device pixel ratio of the screen into account. So, for example, if you open it on a Mac, I don't know about the latest Macs, like the M2 MacBooks, for example, but if you open it on my 2019 Mac, I get a device pixel ratio of 2, meaning that one CSS pixels maps to two real, like, hardware pixels. And we have to take this into account. Otherwise, we will get, let's say that my screen is actually at 2000 by 2000, just to make the math simpler, but I'm rendering at 1000 by 1000 and we will get aliasing, right? We have to account for the real hardware pixels. And we have to do this in WebGPU, and we also have to do this when we are going to program in Swift and do the metal animation. So DPR is device pixel ratio, and I'm just going to do the DPR times DPR. And that's fine and good. So now this canvas is sized in hardware pixels, but we still need to present it in CSS pixels because that's ultimately what the browsers will show, right? So to that, I'm going to do canvas style set property, and it's going to be width. And I'm going to do the string interpolation like inner width pixels. And I'm going to do the same thing with the inner height and height. Yeah. And now we can set the viewport of our GL context to 0, 0. We can do the canvas dot width here. And this will give me the canvas width and height of, obviously, right, with the hardware pixels size. Or I can do the GL drawing buffer width and GL drawing buffer height, which these two values will map to these two values. Yeah. And just to make sure that it works, I will set the GL clear color. This expects 4 arguments: red, green, blue, and alpha. And finally, I'm going to say GL clear, GL clear, GL color, buffer bit. Hey man, yeah, I'm good, and I'm happy that you managed to join us. And we already started, but like we are really just in the beginning. I'm sure that this stuff is not news for you. So if you refresh, here is our WebGL2 context, which is red, right? That's just as we expected. And we see that we have this annoying default CSS styling around the edges. So let me quickly do the style. And I'm gonna say, I think it's body. It will have a margin of 0. Yeah, and here it is. So now our canvas is full screen, it's sized correctly, and it's red. But I don't want it to be red. I would like it to be some almost white, let's say 0 0.8, 0 0.8. Let's do 9. Yeah? So we are going to start by writing by drawing one single pixel in the center of the screen. And this process involves um, the WebGL rendering pipeline. And this rendering pipeline, if you start reading about all these graphics API, that's really like an overloaded term. But essentially, what it means is that when the GPU draws our stuff, it needs to know like all of these things that it should take into account. For example, what is the final position? What is the final color? Is there blending involved? Are you using any textures? So all of these ingredients actually create this render pipeline. So if I do a quick Google search of WebGL, OpenGL rendering pipeline, and maybe even to the OpenGL embedded systems, which WebGL is based off, we can see that, okay, we have the vertex specification, we have the vertex shader. We don't have these parts actually. We have the post-processing, the primitive assembly, the rasterization, and the fragment shader. And like, I just want to give the point your attention that many people, when you say WebGL or WebGPU, they immediately start thinking 3D graphics. But that's really not the case. What they do is that they are very good at rasterizing pixels, right? Yeah. So GPU is really good at three things actually. It has a special instructions to draw triangles. It can store the results into frame buffers, which is this rectangular area. Imagine it's just an image, just one rectangular area. And then it can blend this image with other images, just like Photoshop, if you have used Photoshop. So in order to draw a single pixel, we basically have to say, okay, let's say, okay, draw one triangle into this frame buffer and present it to the screen. So I usually what I do is we have to write shaders because OpenGL, it expects us to write these small programs that run on the GPU, and they are responsible for setting the position of the property of the point and setting the color. Yeah. So I'm just going to type it out and we can talk about it a little bit later. So first thing I'm going to do is create a function. It's going to be called create program, create GL program. I set it to light gray. You can do anything, like any combination of colors, as long as it's in the 0, 1 range, right? And as long as your alpha is 1. So I'm gonna specify here vertex shader source and fragment shader source. This will be the sources of my WebGL program. And here I'm going to create a new function, which is going to be create GL shader. It will have a type and a source. And I'll say const vertex shader will be create shader, GL shader. The type will be gl.vertex shader, like so, and vertex shader source. And then the const fragment shader will be the same thing, create GL shader, but this time it will be a GL fragment shader, yeah? And we will have the fragment shader source, like so. And finally, we need to compile a program with these two shaders. So I'm going to say const program, going to be GL create program, GL attach shader to program, and vertex shader. Like, I just want to bring your attention that OpenGL and WebGL, since there are these legacy APIs that are really old, they basically are back from the 90s, if you think about it. It was the first version of OpenGL. And each new version of OpenGL basically carries all of this baggage from the past, from the 90s. So the way OpenGL works is, okay, let's say we, for example, in JavaScript, we would, and this is pseudocode, we are accustomed to creating objects and executing stuff on these objects, right? Like, for example, I can say that I'm going to have, I don't know, like a person, and it's going to be a new object, like so, and then person dot talk, right? But the way WebGL or OpenGL works is actually we would say, okay, const person is, I don't know, like my app dot create person. And then to make this person speak, I would not execute commands on him, on the object. Rather, I would say my app make person talk with my person. Yeah. Or even taking it a step further, WebGL or OpenGL would rather do my app set active person. Yeah, it will be person, and then it will say person talk. And when it says person talk, it will know which person to use because we set it on the previous line. And it's a global, like a state machine, right? So it can have only one person talking. And then I can say like, okay, const person2 is my app, create another person, right? And then I'm going to say here, create set active person to be person2. And then this time when I call person talk, it will actually be the person two talking. Yeah. So it's this like kind of inversion of how you do things. Is this global state object? We don't really execute things on the objects themselves. Rather, we always use the GL context to work on these objects indirectly, right? It's this indirection. So when I do program, I don't say like program attach shader, vertex shader, right? No, I say, okay, GL attach shader to this program, this shader. So I'm gonna do the same for the fragment shader, like so. And finally, I have to link this program. And let me quickly go and create my create shader, create GL shader function. So for those of you who don't know the shaders, they get their name from the 90s when GPUs were really new and actually there was no shaders. And when they first released these things that these programs that you could run on the GPU, they had very limited use and they were mostly used for shading. They were mostly used for lighting. Yeah. So the name kind of stuck, even though nowadays there is all kinds of shaders. There is geometry shaders and tessellation and vertex and compute shaders. For example, WebGPU has them and Apple Metto has the compute shaders. Still, they're called shaders just from this kind of like past. So these shaders are usually called in language that's derivative of C or C++. In our case, it's like derivative of the C language. It's called GLSL, which is graphics library shadings language. So we need to compile them. We need to give them to the GPU as a JavaScript string, and we need to compile them to a valid shader. Yeah. So that's why the source, perhaps a better name, is the shader source as string, right? And this is type of shader. WebGL supports two types of shaders, the vertex shader and the fragment shader. Yeah. So I'm gonna create const shader is GL create shader, and this function gets a type of shader parameter. And then I'm gonna say GL shader source, and again we see this inversion, how we call stuff. We don't say shader.add source, no, we say gl.shader source for this shader, and I'm gonna pass the shader source as string, like so. And at this point, I have fed it, like I have given the shader string, right? Now I need to compile it on the GPU. GPL, GL compile shader, yeah? And I'll say compile this shader that I just created. And I will return it. And here usually, if we write a wrong shader, if we have a typo, for example, or we forget some special symbol, our shader will not compile, right? And our program will kind of crash. So we need to handle this case. And I'm going to say if GL compile status, sorry, it's GL get shader parameter for this shader that I just created. And the parameter that I would like to know is the GL compile status. If this is not true, meaning that the shader did not compile, I'm going to say a throw new error, error compiling. Uh, we have the type of shader here. So if the type of shader is the GL vertex shader, then I'm going to say, is this short ternary if else I'm doing here, just for better logging. So error compiling vertex or fragment shader, like so. And I'm going to say on new line, so GL get shader info log for this shader. And this hopefully will tell me what exactly happened wrong, right? But if this is not the case and it actually compiled successfully, this clause, this if clause will be ignored and I'll return my shader, yeah? So at this point, we have created our two shaders. We have the vertex shader, we have created the fragment shader, yeah? But we need to link them together. And when we link them, we are gonna create the so-called GL program. And this program will actually allow us to use these shaders for drawing on our screen, yeah? So I am linking it, and just as compiling the shader, this operation might actually throw an error, right? So I'm going to say if GL get program parameter, right? Like in the shader function, it was get shader parameter, but rather now I'm using the get program parameter for this program. And this time I'm not interested in the compile status, rather I'm interested in the leak status. So if this is not true, I'm going to say throw new error and error linking GL program. And on the next line, GL get program info log for this program. Hopefully this will tell us exactly what went wrong. But if this is not the case and we manage to link our program successfully, then let's do a return program. Yeah. So let's now create our GL program, right? Like up until this point, we basically just used the, these were just helper methods. So now we can use them. So I'm going to say const GL program is create GL program. And here now we need to give it two JavaScript strings that will include our shader source, right? And I can write them up on top and say const vertex shader source. And since we are dealing with WebGL 2, WebGL 2 has this weird, how should I say, requirement where you have to actually set the version to be 300 ES. And I think this is the syntax, and it's very important. It's the first thing you type. Like this, I believe is not valid, right? It has to be literally the first thing you type. But I'm not 100% sure. So let's check the WebGL 2 fundamentals. This website is really cool. You can use it as a resource as well. So shaders and GOSL. And okay, he's doing this. So unlike me, it needs to have a space and you need to drop this one. So the vertex shader will receive an attribute, which will be a vec4 of a position. And I'm going to explain the syntax. Just please bear with me. Let's type it out. The void main will be our entry function into the program. If you have done any C or C++, like you should be, yeah, this should be very familiar. And I need to set up the GL position to be just to a position, like so. And as I said, the vertex shader, it needs to set the position of each vertex. So it has this reserved keyword, which is GL position, doing it. But in WebGL2, actually, we should not be using the GL position. Rather, we have this now out. Uh, how did he do it? I always have this. So we actually have to specify ourselves which variable are we gonna say send down the line. So the way it works is that we have the vertex shader, which talks to the fragment shader, which outputs on screen, right? So we are at this point, like we are here right now. So we need to send a position, and I'm gonna say like on the next line, sends a position for each vertex, like so. And then the fragment shader, we can say that sets a color for each pixel and outputs on screen. I think that's pretty, yeah, I don't need to write. So this program will execute for each vertex, and we need to, oh, sorry, it should be out. So is it GL position now? Okay, so actually it is GL position. I was wrong. This is this reserved keyword that we need to set, right? And you might notice that, first of all, we are going to start doing 2D graphics. So we are going to be interested in the XY. And once we go into 3D, we have the X, Y, and Z, obviously. And there is this extra special W, which I'm not going to go into details right now. Once we start going into cameras and doing proper 3D, we can talk about this. But for now, we send it a position, and we're going to output a position. And then I'm going to say a fragment shader source. And at this point, we are at the second step, right? At this point, we are in the fragment shader step, like so. And here we just need to set a color. So we have to specify the precision of our float. I'm gonna do high p float, and I'm gonna say out float for out color. Basically, we need to send the final color of each pixel. This function will also have a void main, and I'm going to say that out color will be float for red, like so. So now we have the vertex and the fragment shader sources, and we can use it in our GL program. Vertex shader source and the fragment shader source, like so. And hopefully now, if I console log this GL program, it's not going to show me anything like fascinating, but if we get no crashes, then it means that we are successfully compiling our GL program, right? So, okay, we can see that immediately this compiling vertex shader is throwing me errors. And now it is complaining to me that I have a version syntax error because I believe I forgot the hashtag. And then I have another illegal word, which is attribute. And it's complaining about me using attribute because I believe in WebGL2, actually we should be using in. Syntax error or GL position is equal to a position. Apologies, I have to consult with this. So for, okay, they're using in, right? It's not like WebGL1 where this would be attribute. So in vec position, in vec4. And oh, why is it complaining? Create geo shader. I mean, what is this? What main? I don't even need this. Yeah, it's complaining like you need to specify that it's GeoSL version 3, right? Which I'm doing here in vec4 a position, and I'm setting it to the void main. Is GL position to be equal to a position. Oh, how very. Am I typing this correctly? Looks like it. And I'm compiling the shader. I'm creating the vertex. It's a GL vertex shader. Oh, the fragment shader should be using rather a create GL shader, I guess. And out. I need to specify the same version for the fragment shader. And out color, it's out float 4. It's rather vec 4 out color. And gosh, I'm doing float 4 because that's like in WebGPU. But hey, here we are. Yeah. So like, did we all manage to get to this point? Do you have any questions up until this point? Cool. We don't. All right. So we can continue. We have our vertex shader and our fragment shader, and now it's time for us to draw. So we said that we are gonna draw a single pixel on the center of the screen. So I'm gonna say that my const position is going to be a new float 32 array. We have to use typed array. It's this special JavaScript arrays that are pretty much like you cannot escape them in WebGL. And I'm gonna say that the position is gonna be at 0, 0, 0, right? And first of all, we need to create a buffer to draw this. So I'm gonna say const buffer is going to be GL create buffer, and I can even say, okay, this is going to be my vertex buffer. So I'm gonna say GL bind buffer. Again, we're doing this indirection, right? We're doing this indirection with the OpenGL way of doing things. And I'm going to do the GL array buffer or vertex buffer. And again, I just want to point out, we have the buffer data to GL array buffer. The second argument is the size and usage. The second argument is actually the typed array that I am passing. So I'm going to pass this one. And the usage is going to be GL static draw. Without going into too much detail, this means that we are going to send this array only once. We are not going to keep updating it every frame. We are just going to send it once. And again, this indirection, when I pass data to the GL array buffer, I'm indirectly passing it to the vertex buffer. I just want to like nail this, really make sure that this comes across. All right. So we have created this buffer and we have passed our position array into it. And at this point, I would like to do function draw frame. And this will get a timestamp. And first, I would like to move this code, which sets the viewport and the clear color. And I want to like to set them up on each frame. We don't really have to right now, but once we get into more advanced animation, then that would come in handy. And I'm gonna call the request animation frame on it. Is a request animation frame like known to you guys? Should I explain it? It basically allows us to run animation synchronized with our monitor refresh rate. So um, it will basically allow us to run this function as fast as our hardware allows us, our computer allows us, and synchronized with our monitor refresh rate. And I'm gonna call it from within the roll frame. So this method will start calling itself recursively, right? So if I, for example, like log, I don't know, like 1, 2, 3, we'll see that this is getting called progressively, right? Recursively over and over. And that's how we will achieve animation later on, by calling this method over and over again. All right, so we have our program, right? We have our buffer. Now we need to instruct this program how to consume this data from the CPU to the GPU and draw it. So first of all, I would like to say GL use program, and the first argument is the GL program that I'm interested in, like so. So in order to pass stuff from the GPU to the CPU, sorry, from the CPU to the GPU, we actually need to get the address of this variable. We need to query the GPU and get the address of this variable, so we can use this basically a pointer to this memory address and feed data from the CPU to the GPU, yeah? And in like regular C++, in regular OpenGL with C++, for example, or with Metal, you don't have to do this, but with JavaScript, you can just use the memory address, right? You can just use the pointer and directly feed data to it. But JavaScript does not allow us to do this because for security reason. So we have these extra methods that allow us to pass data to the GPU. So I will do something like here, and I'm gonna say const a position location, and I'm gonna say GL get attrib location inside this program for the name of, how did I call it? A position, like so. And this will return me, if I log it, program is not defined, it's a GL program. This will give me index 0. So whatever this means, it means that this variable is currently residing at position 0. So I have obtained it, and now I can send stuff to it. That's the important part. So to send stuff to this memory address, first of all, I need to enable it. GL enable vertex attrib pointer, or was it just vertex attrib? I have to console because WebGL is funny. It's full of like funny function names, such as enable vertex attrib array, and this will take the location of my variable, so it's going to be a position location. And then I'm going to say GL vertex attrib pointer. And okay, so we have array of 3 values, right? 0, 0, 0. But yet in our vertex shader, we expect a vec4. So how does this work? How is this going to be mapped to this? Well, we have to instruct the GPU how to actually unpack this data. It's not enough just to send it, right? That's the thing. You have to instruct it also how to unpack it. And to do this, we have to use this method. And if I look at the IntelliSense, first of all, I have to give the index of the location of the attribute that I'm interested in. That's easy. I have it. It's a position location. The size that I'm feeding it is 3 because my JavaScript array is 3 values. The type is going to be GL float. It's not normalized. There is no stride and there is no offset. Yeah? And still, we are clearly passing 3 values, yet this one expects 4 values. And the way it works is that if we do not pass, so we have to pass X, Y, Z, and W. So if we pass only X, WebGL will autocomplete for you. If we pass just X, Y, WebGL will autocomplete for you. And if we pass X, Y, Z, still WebGL will autocomplete for us, unless we explicitly type them all out, right? And send them like so. So when I send 000 here, actually WebGL will unpack it to 0001, right? Okay, so at this point, I have enabled the vertex array pointer. I am using the active program. I have to bind the buffer that I'm interested in, and this is the this is the GL array buffer, and is the vertex buffer, right? I'm binding it. I'm binding the buffer. I am enabling the memory location, and I'm instructing the memory location how to read the contents of this buffer into the GPU, right? Finally, I am using the program, and now I think with that being said, I can say GL draw arrays. I would like to draw a point. The first is at index 0 and the count is only 1. I have 1 point, yeah? So, guys, maybe we can see a single point. And hey, I see a single pixel in the middle of my screen. So I'm gonna come here and there is another reserved keyword in GLSL, which is point size to be, let's say 20, yeah? So now it's a 20 pixels size. So did we all manage to get here? Do you have any questions? We're at 2 people watching. I mean, I hope, really hope you guys are getting some value from this. So you don't have much competition. If you have any questions, like please shoot away. No? All right. Um, in that case, I'm gonna commit. I'm gonna say like render a single point. And I mean, should we continue? Should we call it a day? Call it a night? I'm thinking like streaming on weekends, but I guess I can also do evenings as well. But like for example, like which part would you say confuses you, Mr. Fluffy? Like does everything confuses you, or do you get it up until this point, up until some point, and then it kind of stops making sense? So like it's not the shaders themselves, rather the steps about the drawing. It's basically like think about it that way. You are running JavaScript on the CPU, yeah? And when you write HTML, yeah, sure, okay, I get it. So think about it, like when you write JavaScript, you do, for example, like normal Canvas 2D, or you do SVG, or you do HTML and CSS. You're just using the JavaScript, you're just using the CPU, right? You are making your CSS animations and whatnot, but you're just basically running JavaScript on the CPU. But with these shaders, you're setting extra processes that are to be run on the GPU. And these processes by themselves, they are kind of dumb. They don't know anything about anything. They just allocate some memory for you, and they know that in our case, for example, they will expect a vector with four floats. So let's say that like one float is represented by 8 bytes, sorry, by 32 bits, right? So basically 4 bytes. So for four vectors, let's say RGBA, it will allocate 16 bytes. And like that's pretty much it. It will just set up this process. And then it's your job from JavaScript to give stuff to this process so it can run. And you have to make this bridge from the CPU to the GPU. So from the CPU, you have this array, right? But GPU does not understand what is this array. It just expects 16 bytes, four floats. It does not care how things look on JavaScript. So in order to do that, you need to create a buffer. And this buffer, which we create here, you bind it. And when you say buffer data, it will take this array, which is float 32, which is basically is like 32 bits by float. And it will say, okay, this array will be 32 times 3. Basically, it will be 4 bytes times 3, it will be 12 bytes. It will set it like this. And then when it's time for drawing, you will bind this. And now the GPU will know, okay, I'm expecting like this 12 bytes, right? You enable the position and you will say, okay, I'm sending you 3 values. Each of them is a float, meaning 4 bytes. And then times 3 is 12 bytes. Yeah, exactly. It's the whole pipeline. Exactly. You have to make this bridge and you have to explain everything. I am sending you this type of bytes. They're floats. And now you have to draw with them. Yeah. And now it's actually much easier for us to start like drawing more complicated shapes because as you said, our pipeline is set up. Yeah. So this means that I can very easily now come and say here, 1, 0, 0. And I'm just going to format it like so. Yeah, I mean, if it helps you, I think the best way to kind of get it is just like write it over and over again. That's how I learned it. But you're very right. I think if you, let me just see, there used to be this WebGL cheat sheet. And, okay, there used to be this very handy uh, cheat sheet. Or I think there is also this WebGL Gregman, WebGL lint, WebGL fundamentals. He had a really nice demo. WebGL state. Oh yeah, this one, state diagram. So if you run this demo, I'm sending it to you over here. You can see that he gives you the source code. Oh, come on. For, let's say, a single triangle, yeah? So he gives you the source code, which is basically what we just wrote, yeah? And you can execute it step by step. And step by step, he gives you very visual feedback what exactly it is. And okay, here is the program, right? And we have attached a vertex shader and a fragment shader to it. And it's expecting position, which is going to be a float vec, right? It has one attribute and no uniforms. So if you keep replaying it, you will see how the whole pipeline is built and you get the triangle. And okay, this is a very simple example, right? Like, but if you do like cubes, 3D cubes, your pipeline will inevitably end up being more complicated. And at some point, you output this on the screen. So I think that's a really cool way for you to maybe get a better understanding of it. But what you said is right. We are configuring the pipeline, and once the whole setup is correct, you execute, okay, now it's time for you to draw, right? And if you, for example, like just as an experiment, if we forget to call this one, right? And I say, okay, draw, but I have not enabled it yet, it will, it will actually work. No way. Okay, that makes no sense, man. Did I? No, that makes no sense. Because, I think because this location that it gives me is zero, right? And I think that zero may be enabled by default because that's weird. But if, okay, let's say that, like, I don't do that. Man, it's still working. Can this be? Because we are doing it zero. Because this is a special, I think it's a special location, so it's enabled by default. Because, man, that's weird though. We are not setting it anywhere else. Yeah, it has like default bindings that are enabled, I guess. Okay, at some point I'm going to break it, no? Yeah, okay, here. I broke it. It says, does it say? Draw arrays, no valid shader program in use. And I think like, I don't want to jump too far into it, but the important part to understand is that WebGL has the pipeline, as you say, but this pipeline is implicit, meaning that I can write all kinds of combinations of commands here, right? Like I can set like textures, I can set cube textures, I can set blending, I can set, I don't know, like buffers, like we did here, right? I can enable attributes and so on. So you can see that this pipeline is very implicit. It's basically a combination of all of these commands together, packaged together, makes the pipeline. But this thing is slow because the pipeline has to always be, how do you say, it has to always be checked if it's correct. Meaning that if I put a cube texture into a 2D texture, whatever that means, obviously they do not belong together. But WebGL will happily accept it, right? And it will not complain. Only when you start drawing, it will actually check the whole pipeline and it will say, okay, hey, you have a problem, right? Like it's kind of the same deal here. It's complaining to me that no valid shader program is in use because it checks only when it hits this point. And this constant validation is what makes WebGL slow. And newer APIs such as Metal, for example, they have explicit pipelines, meaning that you actually create a pipeline object such as const my pipeline. And this is obviously it's like a that does not exist, right? And you say my pipeline is going to use one texture. You like texture count is going to be only one. And my pipeline will have program this. And when it's time to draw, you're basically just gonna say GL use pipeline. And this is an explicit pipeline, and this is what makes it so fast. This is why these new APIs are faster, if that makes any sense to you. I hope this helped. Yeah. WebGPU they do this, uh, and like That's why people say that they are harder and lower level, right? Uh, that's why people say they're harder. There is more typing because WebGL is kind of simple in that case because you just kind of throw stuff in it and you can always make sure that it's gonna be rendered. But over there, you have to really plan and you're just gonna think like, okay, I'm gonna have one pipeline for this and I'm gonna have another pipeline for that. I don't know, for example, have you done like shadows? Do you know how shadows are done? You basically have to render the scene two times, one from the point of view of the light and one from the point of the view of the camera. And then you combine these two views to get shadows. And in WebGL, this is very easy because you draw your GL program two times. One you draw it from point of view of the light and one time from the point of view of the camera. But for example, in WebGPU, it's not that easy because you have to create two pipelines now. Yeah, you cannot just draw it like as easily as WebGL. That's why people say they're harder and there is more typing, I guess. Right. Um, okay, I'm gonna commit. I'm gonna say more, whatever this means. Make sure that it's running. It's running. Oh, okay. I mean, one last thing we can do. I totally forget while we started talking. We can draw 2 points, right? We can do two now. And if I do this, we'll see the second point. And WebGL uses this special, like, normalized device coordinate. So here is my first line, first point. Here is the second point. Yeah, and we can do GL line now. So it's going to be GL line. Sorry, and you can see I created a line like so. I can add another vertex. So it's going to be 0, 0.5, 0, and my count will be 3. I can do triangles. Exactly. That's a line between two coordinates. So if I actually do lines and I give it 3 coordinates, it's not going to display because it's actually lines between every even set of vertices. So 0, 1, 2, but now it does not have another, it doesn't have a fourth vertex, right? If I want to connect them like so, I need to add another one. And let's say this one will be at, I don't know, minus 0.500. And here is the second set. If I want to connect them all, then I can do lines, line strip, I believe. Yes. And as you can see, they do not loop back. To loop them back, I can do, and let me just like do 0.5, like so. To make it more obvious, if I want to loop them back, I can do GL, which one is it? Line loop. And here we are. So we can actually draw, like for example, I mean, we can do it dynamically, like we can do like, okay, let's do something more fun, like const size is going to be 10. Yeah, maybe. Yeah, maybe. So I can do like uh, new float 32 array. It does not accept only array. You can actually give it an integer value and it will allocate an array, an empty array with this size. So I'm gonna do sites and I'm gonna do X and Y. So because I'm dealing with 2D, right? It's just X, Y coordinate. So for 10 sites, I need 20 floats because each coordinate has two floats, X, Y. And I'm going to say for, let I 0, I smaller than 10, I plus plus, and position I plus 2 plus I multiplied by 2 plus 0 is going to be basically X. So I'm going to say whatever this is, and this is going to be Y. So I'm going to say like step. is going to be math.p times 2 divided by the sides. So we get a full circle radius and we divide it by the sides. And then I can say math.cosinus of I times step times radius, so const radius, going to be 0.5, and it's math dot sinus I times step times radius, like so. And finally, when it's time for me to draw, I'm gonna say sides. And of course, nothing gets rendered. Oh why, vertex buffer is not been big enough for this call. Position, its sides. Oh, because before I was instructing it that it needs to unpack free floats, but now I'm passing only xy. So basically my array looks like vertex 1 x, vertex 1 y, vertex 1 x, vertex 2 x, sorry, vertex 2 y, vertex 3 x, and so on, right? So basically one vertex is represented by two floats. It's not by free floats anymore. All right, and here is kind of our circle. And obviously, if I want more resolution, I can just increase the size. Oh, gosh, I'm gonna do size here, like so. And we can get like a more aliased circle, right? And if I switch back to point, we will see our points, right? And that's cool. We can do a triangle as well. I don't know if you know that, but they like in this graphics programming industry, they have the something called the triangle test, meaning that, for example, you like let's say PlayStation 6 comes out and you want to develop for it, and the question is like how long does it take for you to render a single triangle, right? To test the basically you test the pipeline. So how long it takes for you to render a triangle on the screen. So let's see the WebGL test, WebGL 2.0. So we have a triangle at 0.2, let's say, 0 minus 0.2, and then it's going to be at 0.2 minus 0.2, and then it's going to be at 0, 0.2. So this is going to be x, like vertex 1, vertex 2, and vertex 3. And we are still pulling two flows per vertex. And we have free floats. And now we can draw as a triangle, GL triangles. And here is our first triangle with WebGL. Yeah, any questions? Good question. So GL triangles or GL triangle strip, I mean, it really depends on the context. GL triangle strip, let's, let's, to be completely honest, I don't know if I've ever used it. That is an optimization thing, and it essentially allows us to reuse vertices between two triangles. Okay, I mean, we can give it a try. I've never used it, to be honest. I just do triangles. Uh, Even like WebGPU, I don't even know if WebGPU supports the triangle strip. Like WebGPU spec. Uh, if I search for strip, I think like strip index format, line strip. Oh, okay, it has the triangle strip. Okay, I think we can give it a try. So it's like, as you said, it's GL triangles strip. And I guess I have to use four values. So basically, you give it, we have this point, right? We have V0, V1, and V2, but now we're going to give it V3. So with four coordinates, we're going to draw two triangles. I guess that's the idea behind it. All right. So we have the GL triangle strip, and I need to give it yet another vertex, such as let's do 0.2. And if I come, where is my stuff? Here. Uh, it's GL triangles strip, or I think it's like this. Yeah. So I think it really depends on your use case. Um, if, for example, you're doing just a simple 2D slider, you definitely use this triangle strip, right? Because basically you just need four vertices to display your texture. If you're doing some kind of post-processing where you need to render the scene into a frame buffer, like FreeJS post-processing, and then display it back on the screen with the quad, then you can do triangle strip. And I'm sure like in some different like 3D modeling, when you have complex model, they maybe use it for some optimization, but man, I've never used it. What you usually end up doing is you do index drawing where you again you use four vertices, four positions, but this time you pass an extra array of indices. So you basically it's exactly the same idea. You pass four positions and then you instruct these four positions how they form two triangles, but you actually use geo triangles, if that makes sense. Does that make sense? Any questions? Okay. I mean, guys, so what, like, do you mind me asking, like, where are you guys? Like, what times would work for you? Uh, because I would rather like stop at this point, uh, and then we can continue next time. Because I would rather figure out this Vite.js stuff and also, yeah, just spend some more time preparing because, as you saw, it's my first time today, so it was not very smooth. Uh, yeah, perhaps I should make a poll, but like I don't have that many followers to be honest. I don't know how effective is it going to be. Uh, Rather, I would like whatever you guys tell me in chat, For me, it's important that you guys understand and follow along. Are you guys in the Discord? I mean, I know that Gregor, I don't know how to pronounce your name, sorry, he's in the Discord. All right, well, guys, you've been very captivating audience. Uh, thank you for coming. I mean, it was a yeah, totally. I'll send you the link right now. I will send you the here. Please be my guest. Mr. Fluffy, like, do you mind me asking, did you find me through Reddit or like how exactly? Oh, cool, man, cool. Okay, okay, got you. Yeah, please join the Discord and yeah, I will make sure that I post the second one over there. And I guess like I don't know, I have to read a little bit more about this streaming stuff because like I messaged quite a few people on Reddit. Uh, yeah, I don't know. I have to think about how to bring more people, I guess. But yeah, thanks for hanging out with me. I hope you get something out of it, and like, please clone the repo, give it some time. I mean, as you saw, it's not that much code, right? It's rather like how much is like 80 lines of code. Give it a try. Try to paint it different. Try to draw a triangle and like give it some gradient, for example. And yeah, cool. Thanks again. Yeah, you're most welcome. I hope you get something out of it. Cool, guys. I wish you have a great evening in that case. And yeah, I'll keep you posted. And join the Discord. You can always message me there as well. Cool. All right. Well, have a great evening then. Cool. Oh, cool. All right, guys. Ciao.